Chapter 3, Year 9, ICGSE syllabus. Step 1, we will have to create these 5 drawers that I have created for you. Number 1 is density. Number 2 is heat versus temperature. Number 3 is conservation of energy. Number 4 is thermal energy transfer. Number 5 is cooling by evaporations. Oh, sorry. Before that, let me just tell you something that I always tell my student when I start this session is I'm not a physics teacher. What I'm trying to do now is I'm trying to teach you the learning method that works for me, that I've learned over the past many years since I'm student until now. And this method is a combination of techniques, of learning techniques that can help me to be able to learn faster. And I'm trying to teach you the method using this chapter, physics, right? So what I did is I learned maybe a few days before these sessions using the method, and I created a very systematic and organized notes, which you're going to see later. And following these notes, which is from step 1 until step 9, you'll be able to understand this chapter quite well, right? So let's start. Drawer number, there are 5 drawers, and how do we remember these 5 drawers? Right? I think you also play this game before with me on this emotion plus information equivalent to long-term memory, right? For Yunjie, we did this when we were in the campsite. For Jaden, I think we did this in another session. For Xuan, I think you hear about this for like 2 million times already, right? So information plus emotion equivalent to long-term memory. So what I'm trying to do here is I'm trying to create a story that maybe sounds illogical, but it is funny. Funny means it will create some emotions so that it will help you to remember these 5 drawers in sequence. Right. So this is a story that I created. Let's see whether it makes sense for you, to help you to remember this story in sequence. Right. The story is Daddy had a heated conversation with Thor. Captain Cristiano Ronaldo cooled them off. Okay, before that, do you know who is Thor from the Marvel movies?
And the one that's like a mermaid.
Yeah. Okay, let's whoever who doesn't know Thor is a big guy who is holding a very big axe, something like this. Okay.
Oh,
Okay, this guy, right?
oh,
Okay, is in one of the Marvel movie. This guy. Okay, he's holding this axe, which is very big axe.
okay.
Yeah. Okay, so Jaden and Yuan and Xuan, I think you know who is Thor, right? Okay, this guy holding this very big hammer. I don't know what you call this, but let's call it hammer. Right, let's go back to that page. Okay, here. Okay, what time do we start? Let's write down the time. Starting time. Start 8:16. So imagine your daddy, okay? Your daddy had a heated conversation with that guy just now. And that guy is like a very big guy with a very big hammer. And then Captain Cristiano Ronaldo came over and cooled them off, right? So how this story is able to help us to remember these 5 drawers, right? Daddy is D, D is density. Had a heated heated conversation. Heated is representing the heat versus temperature drawer. Conversation sounds like conservation. Okay, so that conversation is linked with number 3 drawer. With Tor. Tor also starting with 2 letters and a bit the sounds like the thermal, TH, thermal energy transfer. Captain Cristiano Ronaldo is representing conductions, convections, and radiations. CCR, right? CCR. Cool them off. Cool them off is representing the cooling by evaporation, right? So don't worry about what is inside, what is the content of the 5 drawers right now. For now, you just worry about how do you remember these 5 drawers in sequence, right? So imagine Daddy had a heated conversations with Thor, the Marvel guy, the big guy with the big hammer. Captain Cristiano Ronaldo cooled them off. Okay?
Okay.
Right. Xuan, are you with us? Sometimes Xuan's mic is not working. Okay, good. Jaden, you are with us? Because I don't see you guys, so I need to have this acknowledgement. I'll always keep asking whether you are understanding this part or whether you are still with me to make sure that the internet is not having problem, because internet might have problem and you might not be in the class and you might not be able to understand fully if you miss one part. Okay, so I will just repeat myself. Daddy had a heated conversation with Thor. So imagine yourself, your daddy, whether it's Keon, whether it's Go, whether it's Dr. Yuhok, right? Had the your daddy is so small compared to the big guy, the Thor, and both of them are having a heated conversations. Then Cristiano Ronaldo, I think everyone knows who is Cristiano Ronaldo, right?
Yeah.
Who doesn't know? Ginger, you know, right?
Yeah.
Yep, okay. So Captain Cristiano Ronaldo came over and cooled them off. Okay. So this is representing the density, heat, conservation of energy, thermal energy, and cooling. Right. Sometimes you will hear me keep repeating about things that you think I already repeat so many times. For Xuan and Jaden, I think you are used to this. Reason is very simple, Yunjie. If I repeat that, because that is very, very important for you to understand and for this case to remember. Right. So by me repeating it, nagging you, you will remember it better. Right. Because all the other steps that is we are going to follow from step 1 until step 9 is going to be anchoring in these 5 drawers. So if you do not remember these 5 drawers, then you're not able to anchor anything on it. If you're not able to anchor, then you will not be able to get the full benefit from this learning method. Okay? So Daddy had a heated conversation with Thor. Imagine that in your brain right now, in your mind. Okay, then Cristiano Ronaldo, the handsome guy who can kick football, who can play football very well, come over and cool them off. Now, that is step number 1. We have done step number 1. Let me pull out the step page. Okay, this is done. Now this is done. Okay. Now let's go to step number 2 until step number 5. I need you to be a bit more patient with me because these steps needs quite a bit of a readings. Okay, so I want to set the expectation. You need to read quite a bit here, but the way that you read today in these 2 hours is not the same as how you read usually. You're going to read it with more focus by anchoring into which drawers that you are reading, you're linking to, which drawer that you're linking to. Hi, Jovin join us. Jovin is my niece from JB. Hi, Jovin. Jovin is from JB. So Yun Jie and Jaden, they are now in Riyadh, like myself. And I think you know Xuan. Xuan also just came back from JB yesterday. Okay, so I will continue. I'll continue. We have already done drawer one, and this is drawer one. And for the benefit of Jovin, there is this story. I'll just tell you in 10 seconds. You need to remember this story, Jovin. Daddy had a heated conversation with Thor. Captain Cristiano Ronaldo came and cooled them off. Right? Do you know who is Thor? Thor is the Marvel superhero, like this guy. Yeah, this guy. This guy who is a very big guy, a very strong guy with a very big hammer. So imagine your father, Robbie, which is so small, so tiny, and trying to have had a heated conversation with Thor, and Ronaldo came in and cooled them off. Okay, so let's go to step number two. Step number two is reading the summary. So this is the notes that I've created. No, stop, sorry. Step number two is reading the keynotes. Okay, this reading the keynotes. So the keynote is only this small part over here. Now, I want you to read it. Even if you do not fully understand it, don't worry. Just read it and find the keywords. Usually the keywords are the one that is in bold. And just read it and focus a bit on the keywords and understand that there are these keywords inside this drawer. So if you realize this is being created intentionally using the drawers, the 5 drawers. Okay, so I'll give you 3 minutes to read from this density until air coolers. You can start now. Sorry. One more minute. 1分钟. Okay, anyone needs more time? Everyone finished reading, right?
Yeah.
Reading means just reading it. Do not need to have a full understanding because we are just 10 minutes or 15 minutes into the sessions. So you will not be able to understand fully at this point of time. And that is normal, right? So let me do this. I have 5 drawers. I will pick one of you to tell me which drawer, what is the name of the drawer. Let's start with Jovin. Since you are late, I'll give you the easiest one. What is drawer number 1?
Density.
Good. Xuan Xuan, what is drawer number 2? Xuan Xuan, your mic is not working. You can type. Ask your daddy to fix your mic. Okay, next time I will get you something shorter. Okay, Jaden, what is drawer number 3? Jaden, what is the name of drawer number 3?
Drawer number 3 is conservation of energy.
Okay, you have to speak.
Conservation of energy.
Exactly, you have to speak to in the direction of your laptop, okay? Because I think the mic is somewhere in your laptop. Okay, Yunjie, what is drawer number 4?
Thermal energy transfer.
All right, drawer number 5 is evaporations, okay? Now, let's go to, let's talk a bit here. The density. So we know that the density is having the keywords related to mass and volume. Mass divided by volume. So what does it mean? It's a very simple math. When the mass increase, the density increase. When the volume increase, the density decrease. Right? Then in the density, we also have regular and irregular volumes. We'll know about this more later. For now, just try to understand that there is such keywords in this drawer. So drawer number 1 is called density, right? And also it's very interesting it will explain why ship floats on the ocean or on the water. Although ship is something that we know is very heavy and it still floats. So drawer number 2, heat and versus temperature. There are 2 different definitions. Heat is the total thermal energy of the vibrating particles in an object. Temperature is the average energy. I'll give you one very simple example. You have a glass of water. The temperature is, let's say, 50 degrees Celsius. You have a big pool of swimming pool, like in your school, in Jie, and the heated water swimming pool is also 50 degrees Celsius, right? So what does it mean? For the temperature, they are having the same temperature, 50 degrees Celsius, the small glass of water, and also the big pool of a big swimming pool with a lot of water inside. But the total thermal energy is different. The total thermal energy of the swimming pool is bigger than or is larger than the glass of water. Both are having 50 degrees Celsius, but totally having 2 different thermal energy. So thermal energy, the total thermal energy is for the heat. Temperature is for the average energy of the particle in an object. Then there is something called absolute zero. You'll know about this later. Conservation of energy, right? This is when your daddy is having a heated conversation with Thor, the big guy. So conservation of energy is talking about energy cannot be destroyed. You can only change and transfer, and the total quantity of energy in the system remain constant. So energy is something that is so special and unique that you can never destroy it. It will just change from one form to another form. We will know this in more detail a bit later. Okay. Then thermal energy transfer. This is the Thor, yeah, the big guy, the Marvel superhero, right? And also the Captain Cristiano Ronaldo. Captain Cristiano Ronaldo is CCR. CCR is linked to conductions, convections, and radiations. Okay, we will know about this, the detail, a bit later. Don't worry. We are just 20 minutes into the sessions, so don't worry if you do not understand it, and that is normal. Then the last one is the Cristiano Ronaldo captain came to what is he doing? What is he trying to do? He's trying to cool off between Dr. Wong, which is Yuan Xuan's father, and also Thor. Okay, so that is related to evaporation. We are also going to learn about evaporation later. But for now, you just need to know that there is something related to the energy of the high energy particles, and then it will decrease after a process, right? So these are the 5 drawers, and we have done step 2. Now we have completed step 2, which is this part, reading the keynotes. Now, stay with me. There's still a bit of reading need to be done. Right? I know it's very boring, but stay with me. At the end of these 2 hours, you'll be able to understand this chapter quite well. But I need you to commit to these 2 hours. Don't be disturbed or distracted by your WhatsApp messages or your TikTok messages, right? Just focus, just give me your 2 hours, and I hope that you'll be able to learn something extraordinary today. Right, so let's go to step number 3, read summary. Okay, how is this? What is the drill of this? Xuan, Joanne, and Jaden, I think you already done this like maybe 5 or 10 times, so you know what to do. I'll take 10 seconds or 20 seconds to explain it to Yunjie. What do you need to do with these steps? What do you need to do is, I think I've written down somewhere. Let me just pull it out. Wait for a while. So, stay with me, just bear with me for a while. Yes. Okay, so this is the drill. Let me show you what you need to do. So Yunjie, you see there are 3 windows on the left, on your left, on your right, and somewhere in the middle. So let's focus on the somewhere in the middle now here first. Step 3, you have to read the summary. And step 1, you have to read the notes. Note is on your left. This part. This part is the notes. Then you need to identify which drawer it belongs to, or which subdrawer it belongs to. What do I mean by drawer? You remember the 5 drawers that we had? Yes.
Yeah.
So when you read here, you need to intentionally, although it's very obvious, right? I've written here very obvious drawer number 1, but I need you to intentionally still tell yourself that this part is drawer number 1. All right. Or which subdrawer. Let's say you are more advanced now. You created even your subdrawer in drawer number 1. You have a subdrawer of density. You have a subdrawer of regular versus irregular. You have a subdrawer of ships. If you are able to do that at this point of time, then it's even better. So whatever that you read right now, this is related to drawer number 1, subdrawer number 2. Okay. So once you finish these steps, ask yourself, is this a new information or is this a new understanding? What's the difference between new information and understanding? Information is, for example, let's say I did not write here density versus density, the formula over here, the density formula, but you see over here, right? So imagine this is not there. Then this is a new information that you discover while you're reading this. When you're comparing with your reference, your keynotes, your keywords here is your reference. Then there is a new information. New understanding is something that you understood. Is not just an information, but you understood. When there is a new understanding, then you also intentionally pick it up and put it inside your drawer. Put it inside a drawer. So by now, you should be able to have 5 drawers that you created virtually inside your brain. And this drawer, you need to be able to fill up informations or knowledge into that drawer. Okay.
I had.
Okay. Is clear now. So without explaining, without boring you more, let's continue this part. Okay, I'll have this without boring you more, not boring you more. Sorry. So you're gonna have focusing on this left window, right window, and also if you've forgotten what you need to do, this is the reference. So we will start by having a timer of let's start with 1 minute for you to read from here to here. Okay, let's start now. I think 1 minute is a bit too short. I'll give you 1 more minute. Okay, we finished the 1 minute. I'll give you 1 more minute. You can continue to read. If you finish reading it, if you're a fast reader, continue to read it again. Another 20 seconds. Okay, done. Now, when we read this, can somebody tell me which drawer is this? By the way, I'm asking very obvious questions, but just bear with me. Can somebody tell me which drawer is this?
Density.
Density drawer number 1, exactly. Okay, and it is related to, if you want to go to the sub drawer or the sub items over here, is related to density, the number 2, and also the number 3, regular versus irregular volume. Right? Anyone having any objections? No objection, then we'll go straight to the next one. Don't worry if you do not fully understand every words or every sentence or the concept of 100% of this. You're gonna capture it as we go along, because we are still in step 3, right? So let's read. Let's see. Okay, this we have to divide it into 2 parts. Okay, let's read this part. Let's read this small part, 1.2, in 1 minute. Start now. Thirty seconds. Ten seconds. Okay, finish. Now, if I have to link it with the drawer, this is obviously also is drawer 1, and it is somewhere here, talking about the float and also the sink, right? And also what are the new informations? I would say that the new information is about the water density. Water is having this 1.0 gram over centimeter cube. It's not over here. So there is a new information. Remember this step number 3? There's a new informations that we need to capture and put it inside our drawer. You have to build your 5 drawers virtually in your brain right now, right? 5 drawer, and open the door of the first drawer. The 4 other drawers, close the door. And what do you see inside the drawer? You see the density formula inside the drawer. You see the regular versus irregular shape inside the drawer. You see now one droplet of water, which is representing this 1.0, right? Then anything else, let's say you want to put this steel, this 8.9 into your drawer, if you think this is important, okay, then there is a steel that is 8.9 inside your first drawer, right? So as we build this drawer, Yunjie, your drawer, Jaden, your drawer, my drawer, Xuan drawer, and Joanne drawer, the things that inside each of our drawer will be a bit different. We started with something similar, but then as we build it, it will become different, more and more different. The variety is becoming bigger and bigger, right? Now, let's go to the same exercise. Let's start 1.3 in 1 minute. Let's do it 1 minute. 20 seconds. Okay, done. So this is drawer 1. And which part of it in this drawer 1? I think it's a new information, right? It's talking about the particle of the gases and talking about the particle of the solids. And also you can relate it with particle of the liquids. I'm sure you have already learned this liquid, solid, liquid, and gases, the state of matters, right? And let's read this last part in a few seconds. Let's start. Let's do it 30 seconds. Ten more seconds. Okay, done. So it's talking about the particles, the density, the particles, the volume, right? How dense is it? Now, before we go to drawer number 2, can Yunjie, you tell me what's the story to help you to remember the 5 drawers?
Your dad is having a heated conversation with Thor.
Yes,
Captain Cristiano Ronaldo cools them down.
excellent. So can you tell me the name of the drawer from 1 until 5 in sequence?
Density, heat versus temperature, uh, conservation of energy, thermal energy, uh, uh, evaporation, cooling, evaporation.
Okay, that's good. That's good. The answer is here. Right. Don't worry if you are referring here, it's fine because this window is a reference window. I will have this window open for most of the sessions for you to refer. So the story is here, the drawers is here, and the keynotes are all here, right? Now, let's go a little bit faster now, since now I think Yunjie, you know the drill, and I'm sure the rest, they know the drill by heart already because they have done this like many times. So let's go a bit faster. Let's do this in 2 minutes. Okay, 1 minute passed. So now 1 more minute. You finish reading because you are a fast reader, read it again and relate it to the drawer or sub drawers. 20 seconds. Okay, let's start with Jaden. Jaden, which drawer is this? Tell me the drawer name. Jaden, uh your mic is off.
So this drawer two.
Yeah, speak towards the laptop, please.
Drawer two.
Yes, what's the name?
Drawer two.
The name.
Or the name of
Yep.
heating versus temperature.
Good. Right, heat versus temperature. Now let's pick who? Pick Jovin. Jovin, are you ready?
Mm.
Can you say yes? Okay. Do you have any new information that, just one, new information that you read in this window against this reference window? Any new information? I'll give you one example. Right, I'll give you one example. You have this sparks from a sparkle that is having a very high temperature, about 1000 degree, but it doesn't burn. Right? It's not mentioned over here. It's not mentioned over here. So there's one new information. Can you now identify one more new information other than the one that I mentioned?
Sparklers.
Which one? Sparklers? Yeah, sparklers is the one that I mentioned just now. Any other new information from here until here? 有没有新的 information 是
没有。
你在那边读到的，然后是在这边是没有读到的？
没有。
没有啊。What about 这个 Lord Kevin？Lord Kevin 这边有吗？或这边没有吗？对吧？这样这个就是一个 new information，对吗？可能这个 new information 你觉得不是很重要，不过for now for this exercise we are trying to help you to train this skill of identifying new informations from a new source of reading. Okay, let's see any other new information. Okay, I think pretty much that's about it. The two new informations that is not here having here, right? So this is an example how we perform step number 3 here. Okay, step number 3. You ask yourself, is there any new information or new understanding that you read from here that is not in your drawer? For now, everyone's drawer is about the same. But as we go further into the steps, your drawer and my drawer will be different. Okay, so let's go to the next one. Let's take 2 minutes. Let's start now. Okay, 1 more minute. Twenty seconds. Okay, done. Now, Inje, can you tell me which drawer is this?
Conservation of energy.
All right, drawer 3. Now, Jovin again. Jovin, tell me one new information that you see over here, that you read over here, that is not over here, which is your drawer. Jovin, your mic is off.
Energy transformation.
The example of energy transformation, right? The electrical lamp. You're right, okay? So it is over here, but it's not over here. So once you identify this new information, then you ask yourself, is this new information important? If it is not, okay, leave it. If you think it's important, then now you have to intentionally pick up the important keywords or informations and put it inside your drawer, drawer number 3. By now, you should have opened the drawer. Imagine your drawer number 3 is in front of you, and you open the door of the drawer number 3, and you put this new information inside your drawer number 3. Okay? Your drawer number 3 now is having quite a few items in it. Your drawer number 3 now is supposed to have some items related to cannot be destroyed, something very flexible, and it can change into other form, but it just cannot be destroyed. So whatever you want to imagine, or however you want to imagine that, whether it's like my story, I created a story. I took Elise as the subject of the story to make it more interesting for Injie. That we are changing the shape of a flexible Elise. Imagine Elise is right in front of us, and we are changing her from a human shape into a box, into a circle, into a diamond shape. And she is so flexible. She can change into different other shapes and different other forms and cannot be destroyed. Right? And then later, she got dissipated. He got frustrated and he dissipated. He dissipated into the environment. And that is related to this part, which is the next part that which is already in the 3.2. Right. Okay. Now the last drawer. No, the 4th drawer. We have 5 drawers. So let's do the same drill. Right now, I think everyone already warm up. So let's do 1 minute for this drill. This one, 4.1. 10 more seconds. Okay, done. So this is which drawer? Xuan Xuan. Xuan Xuan, you're typing? Which drawer is this? Xuan Xuan, are you still with us? Hi. Okay, we'll skip her for a while. Let's ask Jaden. Jaden, which drawer is this?
This is drawer for thermal energy transfer.
Good. That is drawer for thermal energy transfer. Xuan, if you are here, thumbs up. Sure. Okay, I send a message to her. Okay. Right. And this is the conduction. Conduction is you remember the captain Cristiano Ronaldo? The C. Conduction. The captain, the conduction, C. Right? So this is explaining what is conductions. If you do not fully you should be able, after you read this, you should have certain level of understanding on what is conductions. Later, when we go into the steps, the further step, you're going to get more understanding. Then you're going to get more understanding. Then you should get 60, 70, 80% of the understanding, or even 100% when you reach step 9. If you do not fully understand now, it's fine. It's normal. If you fully understood, then it's good. Right? So let's take another 3 minutes to complete 4.2 and 4.3. Let's start now. 2 minutes, sorry. One more minute. Thirty seconds. Okay, done. Right. So this is about the convections and radiations. the Cristiano Ronaldo. Very last part, just very last part over here, before we go to drawer number 5. Let's do for 1 minute. Let's start now. Ten seconds. Okay, done. We have a very small part here. Let's go through these small parts, drawer number 5, in 2 minutes. Then we'll do a recap. Stay with me, right? Okay, I know that it's very boring and it's very not so interesting. If you feel that way, just stay with me. We still have 1 more hour. That 1 hour, I will definitely hope that you're going to learn something new. Let's do 2 minutes from now to read this now. One more minute. Fifteen seconds. All right. Now we finished step 3. We finished step 3. Next, we're going to go into step 4. But before we go into step 4, let's do a recap, just to make sure everyone is still with me. Injie, can you tell me the story again? That it will help you to remember the 5 drawers.
Yeah, Dad has a heated conversation with Thor. Captain Cristiano Ronaldo cools them off.
Yes. Jovin, can you tell me the name of the drawer from 1 to 5?
Density,
Okay, number 2?
heat versus temperature, conservation of energy, thermal energy transfer, cooling by evaporation.
Okay, good. So daddy is the density. Had a heated conversation. Heated is the heat. Conversation is the conservation. With Thor, the big guy in Marvel movie, thermal energy. Then Captain Cristiano Ronaldo is also explaining this subchapter, conductions, convections, and radiations. So CCR. And then what is his functions? He came over to cool your father, your daddy, and the Thor off. And that is evaporations. Evaporations is like, by now you already read, it is sweating is part of a example of evaporations. When you sweat, then you are getting your heat is dissipating out. So you are getting colder. Your body is getting colder, right? And that is the reason why humans sweat, to make sure that we do not overheat ourselves. We are getting our heat out from our body, right? So that is the cooling part. So imagine when you are sweating, and then you go into a fridge, or you go beneath an aircon. How will you feel? You feel very cold compared to if you are not sweating. Or let's take another example. You go into a shower and your body is still wet, and you step out immediately right in front of an aircon. How do you feel? You feel very cold, right? Because of the evaporation of the water away from your body skin. Okay, it is pulling out the heat from your body into and dissipate it into the air, transfer it into the gas. Right. So are you still with me? I know it's a bit boring, okay, but I already told you from step 2 until step 5, it requires a bit of a reading. And usually student doesn't like to read that much compared to watching. Watching video will come a bit later, step 6. Okay, Yunjie, are you still with me?
Yeah.
Do you still as energetic as before?
Uh, I was sleeping just now.
You slept just now.
Yeah, like before the class.
Before the class. Okay, yes, yeah, it's early morning. Yes, I should not ask this question. I should ask another question for Jaden and Yinjie. Okay, now, before we go to step 4, if you read this one more time and tell me if now you understood it more than before when you first read it like 45 minutes ago. So let's take 1 minute let's take a few seconds to read it quickly. Let's set 30 seconds. Okay, done. So do you have the same feeling that I do when I was reading this the first time? I do not understand it that much, but now after 45 minutes, I understood it a bit more,
Yeah,
right? You have the same feeling, right?
yeah.
Shen, you're back. Okay, good. So in the next few steps, this understanding on these notes will become more and more. So I just need you to bear with me for another, maybe about 1 hour. And can you do that? Injay, can you do that?
Yeah.
No WhatsApp, no TikTok, no distraction for any social media. Same goes to Jovin. Same goes to Xuan. I don't know where you went to just now, but I'm sure it's something important. And Jaden also. Okay, I need your 100% focus. Right, and I will not let you down. I'm sure after the 2 hours you'll be impressed by yourself. Okay. Yes, Xuan is typing. Let's wait for her for a while. Let's take a small break. Line got problem. Okay, good. That's why I always wanted to have these interactions to make sure that you are still with us. No problem. So I hope the line is back right now. Let's continue. And also, Xuan, you need to fix your mic. Okay, next time. Now let's continue on step 4. FAQ. FAQ is frequent asked questions. So what do you need to do in step 4? Let me replace this with step 4 techniques. Okay, now I will replace this here. So this is to guide you what to do for step 4. Number 1, read the question. Identify which drawer or sub-drawer it belongs to. Then read the answers. And then ask yourself, is there new information or new understanding inside the answer? Comparing to what? Comparing to your drawer, this one, the keynotes. Then if there is, place it in the correct drawer. Whether it's drawer 1, drawer 2, drawer 3, drawer 4, or drawer 5. And there are 8 questions. Let's go one by one. Okay, let's start with question number 1. Inja, can you tell me which drawer is this? I'll give you a hint. I'll give you a hint. 1 until 8, usually they are in sequence. So I do not jumble them up. So usually they are in sequence. So number 1 usually is drawer number 1. Right, just to give you a small hint. Yes, Inja, which drawer is this?
Density.
Density, excellent. Okay, now you finish this and you finish this step. Let's continue to read the answer. Let's start now. Let's do 30 seconds. Or let's do 1 minute. You finish reading, you're a fast reader, let's read it again. All right. So I'm sure, I hope by now you read the answers. And Doreen, any new information or new understanding in these answers comparing to your drawer, which is this one? Doreen, your mic is off. Doreen, we cannot hear you. Or I cannot hear you. Yeah. Any new information or new understanding?
No.
Okay. If I have to choose one, most of them is already here. If I have to choose one, I will say maybe this one. Right. This one maybe is a new information because it doesn't mention clearly in this drawer. It doesn't mention anything about the wood. So this is a new information. You have to put it intentionally and put it inside your drawer. For this is also a new information if you are comparing to what is written over here. But this is no longer a new information because just now we read this before and we intentionally picked it up. Right. For the wood, if you have already picked up just now in one of the tables, then it's fine. Of course, then obviously there's no new information for you for your drawer. Right. Same goes to concrete. Concrete is also shown in one of the table just now. If you have already picked it up, then obviously there's no new information for you. So everything is well known in your drawer. Okay. Now next, let's do the same drill. Question 2. Jovin, tell me which drawer is this?
Density.
Excellent.
One.
Good. Yes, draw number 1. Okay, let's go to read the answer. And then intentionally pick up any new information or new understanding. Everyone, not only Jovin. Let's start. Okay, done. Now I'm going to ask the same question to the same Jovin. Jovin, what is the new information that you think you have here against drawer number 1?
Uh, Cargo, fuel, and passengers are added, its mass increases.
Yes, excellent. That is exactly the new information. Okay. Shen, I wanted to ask you, what is the new information? I'm not sure whether you are still here. You are here? Your line is okay?
Hello?
Oh, yes, I can hear you now. Yes, Shen, welcome back.
For me, it's like the load illness.
What is it?
The load illness.
The load.
The
This
last
one, the load line?
Yeah.
Yes, new information is the load line, the PIMSO line. Right? Okay, so this is you remember when I told you the story, the student A and student B? There are 3 skills that student A, a grade A student, would have compared to student B. One of the skill is the ability to identify new information and then put it into your drawers systematically. So this is what I'm trying to train Jovin. And I asked him I asked her 3 times to intentionally pick up new information. So this is a skill that you need to learn. Right? When you read something, you need to know to identify which is the new information that is not what you have in your knowledge base, in your brain, and pick it up and put it inside. And not just put it inside randomly. Put it inside the right drawer. Okay? Good. Welcome back, student. I'm going to ask you more questions now. Next, let's do this drill. Start 1 minute. Oh, no, sorry. Student, tell me which drawer?
Two.
Which drawer?
Second.
Second drawer, second drawer. Good. Okay. Now, let's read this in 1 minute. Okay, done. Student, tell me what is the new information? One new information.
The larger glass contains more total thermal energy.
All right. Where is it? Let me. I saw it somewhere.
Last slide.
Yeah, this one. Right. The larger glass. Just now, the example that I explained was swimming pool against a small glass of water. Now, this is being explained in a larger glass against a smaller glass. All right. Same temperature, but different thermal energy, different heat. Okay. Now, let's go to number 4. Let's start with Yun Jie. 哪一个 drawer?
Heat and temperature. Heat versus temperature.
Okay. 第二个 drawer heat versus temperature 对了。Now next, read the answer. Everyone, please. Not just Yun Jie. Let's start. 1 minute. Okay, Yun Jie, any new information?
Because the part where it says when the heat is transferred to your skin, the spark's own temperature plummets almost instantly.
Okay, yes, there's a new information. It's not here. You're right. Okay. Next. Jaden, which drawer?
Drawer 1.
Drawer what?
1.
Drawer 1?
Oh, no,
density?
Draw 3.
Drawer 3, yes. That your father is having conversation with the Thor. The conversation. Sounds like conservation. Yeah, by the way, you know what is conservation?
Yeah.
Didn't you know the word? What's the meaning?
Yeah.
No.
Yeah, I know what conserve means.
Yes, conserve the energy, right? Don't waste your energy. Conserve,
To
all right?
save.
Okay. Yes, more or less like that. Okay, let's read this, everyone, please. I'll give you okay, 1 minute. I think by now this is easy. Or getting easier. Getting easier. Okay. Okay. Jaden, any new information that you think? Jaden, any new information from this answer? Jaden, your mic is off.
So
No new information. Right. I think there's no new information as well. Some of you maybe will say that, okay, this is a new information clearly because it's not over here. But I already added these informations when I read in step 3 and step 4. It was there. So this is not reflecting my drawer right now already. My drawer has already expanded more than this. Right? So I think Jaden is also have already captured this part. Okay, let's go to the question number 6, which is a bigger questions. Jovin, tell me which drawer is this?
Thermal energy transfer.
Good, very good. Now let's read, everyone. Let's read this in 1 minute. Okay, finish these questions and 3 more questions, then we take a small break. 10 more seconds. Okay, done. Any new informations? Anyone? 4 of you? Anyone? Inje, you want to say something?
Yeah.
Yes, wish.
When it says this is why double glazed windows with a layer of argon gas trapped between the panes are effective at reducing heat loss.
Yep, I agree with you. This is a new information. So take this new information, and if you think that it is important, doesn't mean that all new information is important. You think that it's important, and then you put it into your conduction sub drawer under the drawer number 4, right? So conduction is for the liquid, sorry, for solid. Conduction is for fluid. Fluid is liquid or gases, right? So convections and conductions, there is different state of matters, process of all different state of matters, right? Now let's go to this part. Okay, I'll just show you the convection also, just in case you did not have time to finish. You can complete in this 1 minute together with the radiations. Let's start now. Ten more seconds. Okay, so radiation, I think the key information is it is able to radiate or transfer the energy in a vacuum. You know what is vacuum, right? Who doesn't know what is vacuum? No one. Vacuum is a space where you have nothing. No oxygen, no nothing. There's nothing. There's no particles, no atoms, no electrons, no protons, no neutrons, nothing, zero. But you are still able to travel the heat. The heat is still able to travel. That is called radiations. So the heat can be traveled in 3 ways, mainly in 3 ways. The thermal energy can be traveled or transferred in 3 ways: conductions, convections, and radiations. Right? So let's go to question number 7, then number 8. Then we take a small break. Okay? Let's start now. I will not ask you which drawer. You ask yourself and you answer yourself. And then let's perform these techniques or this drill. Let's start 1 minute. Okay, this is drawer number 4. I think it's drawer number 4. Right, drawer number 4, where it is explaining the applications of thermal energy transfer. So which is this part. You have the vacuum, you have the silver surface, you have the lid. Right? Okay, last questions in these steps. Obviously, this is drawer number 5 because the name tells you that it is evaporations. So let's start now. All right, that's it. Now let's take a 5 minutes break. Start now. We'll come back after 5 minutes. Hay 1分钟。 OK，全部都回来了是吗？OK，let's continue. Is everyone back? I think everyone is back, right? 英杰、轩轩、Jovin、Jaden. Yes. 英杰 yes. Jovin yes. Jaden, Jovin, are you back? Okay, I think they are. Right now, what time did we start? 8:16. Now is 9:50. So it's about 1.5 hours. 1.5 hours, we have done step 1 until step 4. Right, another, I think, half an hour or 45 minutes maximum. We're going to complete this 5 until 9. There's one more part that is reading. So I need you still to bear with me for this one last steps before we go to the easier steps. Easier step is it doesn't require reading anymore, right? So not so intense. Can we do that? Right, now let's do a quick recap. This time I'll do it for you. So the story, still remember the story? Your daddy had a heated conversation with Thor, the Marvel superhero, the big guy with the big axe. And then Captain Cristiano Ronaldo came and cooled them off. So that's the story. And that story is helping us to remember the 5 drawers in sequence, not just any sequence, but in sequence. Daddy, D represent density, had a heated conversation to represent heat as a second drawer, and conservation of energy as a third drawer. Then with who? With Thor. Thor is thermal energy transfer. And that involved the Captain Cristiano Ronaldo, CCR, conductions, convections, and radiations. And the last drawer is related to cool them off. So cooling by evaporation. Sweating is one of the process of evaporations, right? So if you now again read these keynotes, which is our main reference, I think you understand it clearer now, right? I think you understand it clearer now. You have more understanding on these keynotes. There's nothing changed in the keynotes, in the keywords here, or keynotes. The only thing changed, because you did not see me change any words or any sentences or any points here, right? I did not delete or did not edit, nothing. What is changed? The only thing changed is we took about 1.5 hours to go through the steps, which is step 1 until step 4, and you fill up more information and knowledge into your own drawers, into your own 5 drawers. And that helps you to understand these keywords much better compared to 1.5 hours ago, right? And it's only 1.5 hours. So imagine if we are doing this for other subjects or other chapters, how fast you're going to learn compared to your previous way of learning method. Now, let's continue with our step 5. Bear with me, there's still a bit of readings. So let me just change the technique again to something that's more suitable for step 5. Okay, put it over here and replace it. This is for step 5. Step 5, there are 2 parts, reading guide and quiz. So let's start with the reading guide. Okay, how do you need to perform this drill? Is you read the notes, which is on your left side. You identify which drawer, which is on your right side. And then you ask whether there's new information or understanding that you get from here, and place it into the right drawer, right? Pretty similar to what we have been doing. So let's start now. Here to here. Okay, this is clearly drawer number one and related to density and this part regular and irregular volumes. So by now, I think you know how to calculate the volume for regular objects and how to calculate the volume for irregular objects, right? Using the displacement method. And what is displacement method is explained over here. Okay? Now, let's start for 1 minute this part. Okay, 1 minute is done. This is also chapter drawer number one, density, related to flotations, right? Okay. I'm sure by now, wait, let me go back here. By now, there is not much new informations that you are able to identify, but more of new knowledge or new understanding. Now, I think by reading these steps, you're gonna get more new knowledge or new understanding, not so much of a new information anymore. And that is normal. And that is the right direction to go. If you're still getting new informations, that means for the previous few steps, you were not focusing that as you need to, right? You by now you should be already understand get more new understanding or new knowledge rather than new information. In the earlier steps, it's more of a new information rather than new understanding. Okay, so we are transition into a more mature level of understanding of this chapter. Now let's read from here to here before absolute zero for 1 minute. Okay, Jaden, get ready with your mic. What drawer is this?
That drawer 2.
Yes, when your father or your daddy is having a heated conversations with Thor, the heated. Okay, now let's continue on this small part. Let's do 10 seconds. Okay, I don't think you have any new informations. Maybe a bit more of a new understanding to get you understand it more. This part here, that they have created temperature within billions of a degree of absolute value, absolute zero. What does it mean? It means that they have already went into so much testing into a billion of a degree. So 0.000000001 degrees Celsius, and to reach the absolute zero point, which is this one, right? To be able to prove that the particle would completely stop moving. But the fact is, particle can never be completely stop moving. There will still be a little bit of vibrations, right? Now let's continue here. Drawer number, this drawer. Drawer number 3. Having the conversation with Thor. Right? So this is the part of dissipated energy. Let's continue. We should have taken the whole thing, but it's okay. Let's do it one more minute. Okay, drawer 4, almost there. Stay with me. Let's do the conductions for 30 seconds. Okay, new information, new knowledge, put it inside your drawers. Let's do these two, convection and radiations. 1 minute. Okay. This part here, very small part, and applications, 10 seconds. Done. Last drawer. Last drawer. 1 minute or 30 seconds. I think it's too long for 1 minute. Done. Another 30 seconds. Okay. We finished the step 5 study guide. There's one small part, which is the quiz. There are 10 simple questions. Right. Before that, I want you to quickly read this again from this density right until cooling by evaporations. Let's do 1 minute. Oops, sorry. Okay, done. Finish reading this part. I think by now you should feel stronger that you understand this 5 drawer much better than 1.5 hours ago. Right. And now let's go to the next steps, which is the quiz. How do we do this? Each questions, you need to identify the drawer. For example, question number 1. Then you need to recall the keywords. You need to recall the keywords that is inside this drawer. Let's say drawer number 1. What are the keywords? Those are the keywords here. And I'm sure you already have your own keywords that is more than what is written over here. And then you need to form a short answer. It doesn't need to be a very complete sentence. Point form is enough. Once you do that, you have already form your own short answers in your mind. Then read this answer and compare it with yours. See whether it is similar or see whether it is having new information that you need to store it inside your brain drawer. Right? Does it make sense, Yunjie? Because you are doing it the first time, so I need to make sure that you understood. Right? Okay. So let's do this. Let's do it with Yunjie first. Number one. Can you tell me which drawer?
Density.
Yes. So by reading this, without reading the answer yet, you can already form some answers in your mind. Am I right?
Yes.
Yes. And that answer that you form within, let's say, 10, 20, 10, 15 seconds, just form it up. I'm sure it's going to be something related to the regular and irregular volume of a displacement method, right? Then I'm sure it's going to be something related to how you calculate regular object, then how you're going to calculate irregular object, and I think that's it. And maybe you're going to talk about a little bit about what is density, right? So once you form your own answer in that format, very high level, very just in point system, point format, then you read the answer. Okay, for a regular object with straight sides, you can calculate its volume by measuring the length of its sides and multiplying them together using an equation. Length, width, height. That's for regular. Now, for the irregular object, you must use the displacement method, right, which involve the placing of the object in a measuring cylinder of a water and measuring the increase in water level. The increase is the volume of the object. Done. Right. So this answer is similar to what our answer was when we were forming the answer in a very quick manner. Right. So what is this? How is it going to train? What is the skill that we are trying to train here? Skill number 3. Remember the student A grade student and B grade student. There's also one part. There are 3 skills that they need to A grade student need to build, or B grade student need to build to be able to become A grade. One of the skill is skill number 2, speed of recall. Speed of recall. So I'm helping you to be able to recall the keywords and form it into an answer, and then compare it with the answer that is provided over here. Okay, I hope this is clear. So now let's go a bit faster and go into question 2. Let's do these techniques if you need reference. Okay, let's start. 1 minute for question 2. Okay, question 2 is done. I hope you have done this, which is these steps. Question 3, let's start now. 1 minute is too long. I'll give you 45 seconds. Done. Okay. Is everyone following these steps? Injay, you're fine with these steps?
Yes.
Do you find the benefit of doing this exercise? And do you
Yes.
understand why we are doing this? You understand, right? Okay, that's good. That's good. I hope Jaden, Jovin, and also Xuan, you also is able to follow. I'm sure you'll be able to follow because we have already done this a few rounds. Yep. So let's focus on question number 4, 45 minutes. 45 seconds. Done. 5. Start now. Done. Okay, 6. We have 5 more to go. Stay with me. Start now. Done. 7. Start now. Okay, 3 more to go. Stay with me, please. Start now. Two more to go. Start now. Number 9. Teach you. Number 9 is drawer 5. Okay, number 10 is not drawer 5. You read and tell yourself and answer it. Which drawer? And then continue. Done. Finally, we finished all the readings. Now we go to step 6. Step 6. Let me do something. Wait. Stop sharing. Hey, start sharing.
You ever wonder how a gigantic
你听到他讲话吗？ Do you hear the lady was speaking just now?
Yes.
Okay, everyone, I think. Okay, I see from Xuan and Yunjie. I assume Jovin and also Jaden is also able to hear them. All right. So what we are going to do here, this video is going to explain this chapter. And I want you to intentionally link which drawer it is. Okay, when they are talking about certain certain parts of the video, you need to tell yourself whether this is drawer 1, 2, 3, 4, or 5. Okay. This is to reduce the flying brain problem. I haven't explained to you what is flying brain problem. So it's okay. You just follow my steps. 你看到是什么东西呢？在这个 video 你就要去 link to 哪一个 drawer？ 1、2、3、4、5。Okay. Let's start now.
steel ship, I mean, tons and tons of metal, can just float on water? Or why you get that shivery chill after jumping out of a pool, even on a super hot day? It feels like two totally different things, right? Well, they're not. They're actually connected by just a few core rules of physics. And today, we're going to connect all those dots. All right, so let's get into it. Here's the game plan. We're going to start with why floats in the first place. Then we'll get into the energy that makes things hot. From there, we'll look at energy's one big unbreakable rule. After that, we'll see how all that heat actually moves around. And we'll wrap it all up by figuring out why puddles just seem to vanish. The cool thing is, each idea is a building block for the very next one. Okay, first up, density. Now, this is a word we all hear thrown around, but it is the master key. It's the secret to understanding why some things sink like a stone and other things float. So let's kick things off with a classic riddle. You've probably heard it. What's heavier, a kilogram of rock or a kilogram of feathers? Yeah, you know it's a trick question, right? They both weigh exactly the same, a kilogram.
Okay, I think, yeah, this is drawer number 1, density. And video is 8 minutes. So I need you to give me your 8 minutes, focus on this 8 minutes, listening to the video, watching the video, and also link it with which drawer. Now, drawer number 1, start now.
The real difference here isn't their weight or their mass. It's all about how much space they occupy. And this image just makes it so clear. On the one hand, you've got this big, bulky block of polystyrene, and on the other, this tiny little pile of iron nails. Now, imagine they both have the same mass. Let's say they're both 1 kilogram. See how the nails are just crammed into a much, much smaller space? That difference, that's density. So it all boils down to this really simple formula. Density is just its mass divided by its volume. That's it. It's basically a measure of how much stuff is packed into a certain amount of space. So something with high density, that means a lot of stuff in a tiny space, just like those iron nails. And you know, this is where it gets really cool. You can see density in action right here. If you take a bunch of different liquids and pour them into the same glass, they'll actually sort themselves out. The densest stuff, like honey, sinks straight to the bottom, and the least dense, like oil, just floats right up on top. They refuse to mix, all because of this one simple property. Which brings us right back to our giant steel ship. I mean, a chunk of steel is way denser than water, it sinks immediately. So, how on earth does a whole ship float? Well, the secret is all the air trapped inside its massive hull. If you take the ship's total mass and divide it by its total volume, and that includes all that empty airspace, you get its average density. And that average density is actually less than water. And just like the oil floating on the honey, if you're less dense than what you're in, you float. Simple as that. Okay, so now we've got a good
Drawer 2， 记得啊，不要睡觉啊。Drawer 2。
handle on a super important property of matter. Let's switch gears a bit. We're going to move from the stuff itself to the energy that's buzzing around inside of it. We're talking about heat and temperature. And believe me, they are not the same thing. Yeah, we use these words all the time like they mean the same thing, but in physics, totally different. Think of it this way. Temperature is the average energy of all the little particles in an object. Are they jiggling around kind of slow, or are they flying around like crazy? Heat, on the other hand, is the total energy of all of those particles combined. Just look at these two glasses of water. They make it super clear. In the top diagram, the glass on the right is hotter, a higher temperature. That means its particles are moving way faster, so it has more total heat. Now look at the bottom one. Both glasses are the exact same temperature, but the bigger glass just has more water in it, which means more particles. So even though they have the same average energy, the bigger glass has more total heat energy. Makes sense, right? And this is the perfect kind of mind-blowing example. A tiny spark from a sparkler can be over 1,000 degrees Celsius. That is ridiculously hot. But if one of those sparks lands on your skin, you barely even feel it. So what's going on? Well, that little spark has an insanely high temperature, its few particles are moving at unbelievable speeds, but it has practically no mass. So its total heat is teeny tiny. It just doesn't have enough total energy to actually burn you. Wild, huh? So we've got our matter and
Drawer
we've got the
3.
thermal energy bouncing around inside it. But here's the thing. That energy has to follow a very, very strict rule. You could even say it's the most important rule in all of physics. And here it is, the law of conservation of energy. It's so simple, but it's also incredibly profound. It just says, energy cannot be created or destroyed, only changed or transferred. You can't make energy out of thin air, and you can't make it just vanish. All the energy that exists in the universe has been here since the very beginning. It just moves around and changes its disguise. These diagrams show this law in action perfectly. Let's look at the lamp. You put in 100 units of electrical energy, but you only get 10 units of useful light out of it. So where did the other 90 go? They were transformed into heat. The energy wasn't destroyed, it just turned into a form we didn't want. It's the same thing with the car engine. The chemical energy in the fuel gets converted into movement, sure, but also into sound and a ton of heat. The key takeaway is that the energy you put in always equals the energy you get out, even if it's not in the form you wanted. All right, so energy can't be created or destroyed. It
Drawer
just gets
4.
moved around and changed. But how? How does that transfer actually happen? Like, how does the heat from your morning coffee actually
Cristiano Ronaldo, okay? Captain Cristiano Ronaldo.
get into your hands? Well, it turns out there are three main ways this happens. Let's break them down real quick. First, you've got conduction. That's heat transfer through direct contact. You touch a hot pan handle and the heat travels right into your hand. That's conduction. Then there's convection. This happens in fluids, so liquids and gases, like the rolling motion you see in a pot of boiling water. And finally, there's radiation. This is heat traveling as invisible waves. Think about the warmth you feel from the sun. That heat traveled across millions of miles of empty space to get to you. Now, let's zoom in on convection for a second, because this is awesome. It loops right back to the very first thing we talked about. When the air next to a heater gets warm, its particles start moving faster and they spread out. So it's taking up more volume, but it has the same mass. What does that mean? Its density goes down. And what did we learn about less dense things? They float. So the hot, less dense air rises, and the cooler, denser air from the rest of the room sinks down to take its place. This creates a circular flow of air, a convection current. See? It all ties together. And hey, if you want to see a brilliant example of a device built to stop all three types of heat transfer, just look at a vacuum flask, like a thermos. That gap between the inner and outer walls? It's a vacuum. No air, no particles. That stops conduction and convection dead in their tracks. And the shiny silver coating on the inside, that reflects thermal radiation, bouncing heat waves back where they came from. It's an absolute masterclass in engineering, designed to stop heat in its tracks. Okay, we've made it to our final building block.
Trouble
And
5.
this is where we're going to put it all together, our ideas about energy and temperature, to explain something you've experienced a million times, evaporation. So, picture a puddle of water. Inside that puddle, all the little water particles are whizzing around, but they're not all at the same speed. Some are kind of slow, most are average, but a few of them are moving really fast. Now, if one of these super fast particles is near the surface, it might have just enough energy to break away from all its neighbors and escape into the air as a gas. And that process, that's evaporation. And this brings us right back to that feeling we talked about at the beginning. You get out of a swimming pool, a little breeze blows by, and suddenly you're shivering, even though it's a warm, sunny day. What you're feeling is the power of evaporation right there on your skin. So here's the kicker. Evaporation is a very picky process. Only the hottest, highest energy water particles have enough oomph to escape from your skin. And when they leave, they take all that energy with them. So what happens to the water that's left behind? Well, its average energy level drops. And what do we call the average energy of particles? Temperature. So the temperature of the water on your skin goes down, and to keep evaporating, it pulls heat from your body. That's why you feel cold. And this all leaves us with one last kind of big thought. We've seen how heat always spreads out from hot to cold and how evaporation carries away the most energetic particles. So, what happens if you apply that to the entire universe over billions and billions of years? What does that mean for the future? Well, it suggests a future where all the energy has spread out so evenly that everything, everywhere, is the same lukewarm temperature. A universe where nothing interesting can ever happen again. It's a pretty fascinating and maybe a little bit of a chilly idea to end on.
All right. I hope now your understanding about this chapter is better now. Right. So next step, we are going into step 7. We already finished step 6. Step 7 is listen to podcasts. Okay, we're almost there.
Welcome to the deep dive.
Can you hear the lady just now? Hi, can you hear the lady? Let me try again.
We've gone through a stack of your sources on
Right,
physics.
can you hear? Xuan can hear. 云杰, Jaden, Jovin, 可以吗？可以听到吗？ Okay, good. Now, how are we going to do this? Okay. It's only about 5 minutes. Okay, again, I need you to focus on this 5 minutes. No distraction, no nothing. Just focus. And I'm going to highlight which drawer and which sub-drawer that this lady is talking about at a certain point of time. So just focus on what she's trying to tell you and focus on the highlighted parts. Okay, let's start now.
To distill, well, the really essential ideas for you.
Our mission today is to tackle 5 core concepts about how energy works and how it moves. We're going to look at the rules that explain everything from floating ships to how you cool down after a run.
And we're starting with a great paradox, density. I mean, the sources point out that 1 teaspoon of a collapsed star neutronium weighs about 500 million tons.
A staggering number.
Right. And yet you see these enormous steel ships, thousands of tons, just floating. Steel is way denser than water, so why doesn't it just sink?
It's a great question. And it comes down to a distinction beyond the simple definition of density as, mass per unit volume. Yes, a solid chunk of steel is about 8 times denser than water. It sinks.
But the ship doesn't.
Because it's not a solid chunk. You have to calculate the average density of the whole thing. A ship is basically a huge steel shell filled with enormous pockets of air.
So you take the total mass and divide it by the total volume, including all that air.
Exactly. And when you do that, the average density of the entire vessel is less than 1.0 GC meter. So it floats.
So engineers are essentially designing a gigantic, highly controlled air bubble. That's a great way to think about it. Okay, so the ship is floating, but it needs a ton of energy to move. That brings us to a common point of confusion. Heat versus temperature.
A really critical distinction. Temperature measures the average energy of the particles in an object. Heat, or thermal energy, is about the total energy of all those particles combined.
I was really struck by the example in the sources of a sparkler. You know, the kind you see on holidays. It says it can burn at 1,000 degrees Celsius.
That's right, it's incredibly hot.
So if it's that hot, why doesn't a tiny spark give you a severe burn the instant it touches you?
That is the perfect example of the paradox. The temperature is extremely high, meaning the average particle energy is huge. But the mass of that single spark is microscopic.
So there are very few particles.
Exactly. The total thermal energy, the heat, is actually very, very small. It disperses into your skin so quickly it doesn't cause much damage.
That idea of total energy is a great lead-in to our next point, which is probably the most fundamental law in all of this.
The law of conservation of energy.
Right. Energy can't be created or destroyed. It only changes form or gets transferred. But the key thing for us to understand here is what happens when that energy is dissipated.
Dissipation is just energy spreading out, usually as heat, and becoming less useful. Think about an old incandescent light bulb. You put in 100 joules of electricity.
And you only get maybe 10 joules of actual light?
Mm-hmm. The other 90 joules are wasted. They've dissipated as heat into the room. The energy is still there, it's just not doing the job you wanted it to do.
And that dissipated energy has to go somewhere, which brings us to the 3 ways thermal energy actually moves.
Correct, and it always moves from hotter places to colder places, never the other way. The first method is conduction.
That's direct contact, right? Like a hot pan heating the handle.
Exactly. Vibrating particles bumping into their neighbors. It's most common in solids, especially metals. The second is convection. This happens in liquids and gases.
Okay, so that's where warmer, less dense stuff rises, creating a current, like the air above a radiator.
Perfect example. And the third is radiation.
The one that doesn't need a medium. It can travel through the vacuum of space.
That's the one. It's energy carried by waves. It's how the sun warms the earth. And an interesting side note from the sources, dull black surfaces are the best at both absorbing and emitting this radiation.
Okay, finally, let's bring all this particle energy back home. The cooling effect of evaporation. When you sweat, what is actually happening?
So evaporation is when a liquid turns into a gas. But here's the key. In any liquid, not all particles have the same energy. Some are moving fast, some are slow.
A whole range of energies.
Right. And only the particles with the very highest energy, the fastest ones, can actually break free from the surface and escape as a gas.
And if only the high energy particles are leaving, then the average energy of the liquid left behind must go down.
Precisely. And the lower average energy means a lower temperature. That's the cooling you feel. The liquid left on your skin is literally colder than it was a moment before.
Which explains why something like perfume feels so cold. It evaporates much faster, pulling that heat away from your skin more quickly. Wow. So we've connected the dots from density and floating to energy transfer, all the way to how our own bodies cool us down.
And this continuous transfer of energy leads to one last, pretty provocative thought. If thermal energy always flows from hot to cold, and all useful energy eventually dissipates and spreads out, what does that imply for the long-term fate of the universe?
Where does it all end up?
Well, some scientists predict it will lead to a uniform temperature everywhere, a state sometimes called heat death, where even though all the energy is still conserved, it's so spread out that no useful work can be done. It raises the question, is the universe slowly running out of the ability to change?
All right, interesting question. Now, when you read this again, compared to 2 hours ago, it makes much more sense. Do you agree, Yunjie? And Shen and Jovin and Jaden?
Yeah.
Right? Much more sense. To the level that you might have already reached to a good understanding of what is this chapter about. But there's one small problem. The small problem is after a while, after 2 weeks, it's very difficult for you to still remember all this as like what you are remembering now. So what we are trying to do now is we are trying to create a story that is having some emotion in it to help you to better able to retain this memory or this information. How do we do that? That is step number 8, which is the second last step. Create stories. Okay, this is my drawing. My drawing is very bad, as you can see. So just bear with me. Let me just explain what is this story about. Right, and let's see whether this makes sense. So I'm trying to convert the information that is important per drawer into a story. So you can see there are 5 drawers. So there are 5 boxes, 5 representing 5 stories. So let me explain the story one by one. I've already written the story over here. So let me just explain to you and explain to you how I draw this out. Regular number block, when your younger brother or, they have this cartoon that they like to watch, they call it number blocks. That's what Ren and Han likes to watch when they were younger, much younger. So this number block is regular. That means it is it is of a shape that is regular, not irregular, and dancing on the water. And dancing on the water. What does it represent? It represents the regular. Dancing, it represents density. Dancing sounds like density. Then dancing on the water, it helps me to remember about the float, the ship that is floating on the water, right? So this is how it will help me to trigger back my memory faster. And I put a formula over here, density equivalent to mass divided by volume. I hope this is readable. So a regular number block dancing on the water, right? Then the second drawer is about heat and temperature. How do I translate it into stories? Oh, by the way, this story is my story. If the story doesn't make sense to you, you can create your own story, right? I'm trying to help you to see how I learn, the method that I'm using to learn. You can also apply it on yourself with different story or different ways, right? So let's continue on the second drawer. You are playing the spark fireworks. When we were playing this spark fireworks when during Chinese New Year time, especially for Jorin and also Xuan Xuan who is staying in Malaysia. I think you played this before. 那个烟花是吧? I hope Yunjie also and Jaden. Right. This 烟花, when the spark land on you, it will not cause you pain. But when you hold on to the burning stick, there's having the sparks, then you'll be shouting like crazy. So imagine that you are playing that spark and you intentionally use your another hand and holding on tight to the burning sticks. Okay, I'm trying to create emotions, right? So this is the story. So this is the story. Xuan Xuan looks very pretty on this picture, and there's a spark, this sparkler, and she squeezed tightly on the burning stick, and she shouted, "Pin zero." Why zero? Zero is absolute zero. So it will help us to also remember there is this absolute zero inside this drawer. Number 3, conservation of energy. I use ELIS because ELIS start with E and energy start with E also, right? So ELIS is a very flexible person that we can, like a plasticine, like a plaster, right? We can shape her to any shapes, into a box, into a circle, into whatever that you like. You can imagine, up to your own imagination. And then she is so frustrated and she dissipated into air, right? So that is the story for drawer number 3. Then drawer number 4 is Captain Ronaldo, Captain Cristiano Ronaldo, CR7, run very fast, and then he flies up and radiated into black space. So what does it mean? So Captain Cristiano Ronaldo is solid, right? Because we as human, we are mainly solid. So this is to explain the conductions. This running very fast. The conduction is transferring the energy from one point to another point, one solid, or transferring the energy. So they are vibrating, getting faster and faster. And for metal, it has free electrons that can move the transfer the energy fast, more rapidly. So that is representing Cristiano Ronaldo running fast. And then fly up. Fly up means the convections. The convections is the hotter fluid, whether it's gas or whether it's liquid, is going to be on a high. It's going to be on a raise up to a higher level compared to the one that is less hot, having less temperature, right? So that's the movement of the heated substance. Then radiations. So when he fly up, he being radiated into the black space, into the space, right? Into the space, into the universe, into the galaxy, into those planets, right? So that is to represent the radiations. So this is the story for drawer number 4. Then drawer number 5 is whoever, you, Yin Jie or Xuan Xuan or Jaden or Jovin, your body is wet, okay, whether you come up from a swimming pool or whether you come up from a cold shower, and then you try to stand in front of the aircon. 我们讲吹 aircon 是吗？吹 aircon， 吹一个很冷很冷的 aircon。你想一下，如果你整身湿到完，你现在前面有一个很冷的 aircon，你会有什么感受？我 is very very cold. So I'm trying to create emotions so that the story will make sense for you, too easy for you to remember. Right. So that is step 5. We have created all 5 stories for 5 drawers. Now, why is this important? Why is this important? If you remember, I also told you before that human is very difficult to memorize in terms of text. Right? In terms of text, it's very hard to memorize things or remember. But in terms of story, especially emotional story, whether it's logical or illogical, doesn't matter. As long as it is emotional, then it's very easy to remember. Right? I'm sure, Yunjie, by now you already remember the story of conservation energy, right? Because you love Elise so much that you make her into any form or shape that you like. Okay? Then Cristiano Ronaldo maybe is a bit difficult because I don't know. Maybe it's easier for Jaden because he loved Cristiano Ronaldo. Or any other story. I think this story is also very easy to remember because you are being hurt by holding tightly on this burning stick, right? So once you have this story being draft out, created, it's easy for you to draw this picture again. If you draw this picture again and again, let's say you draw 10 times, 10次啊，你画10次啊, do you think that you will still remember? Do you think that it's easy for you to forget this story? No, it's very hard for you to forget this story, right? And once you imagine, in 3 days' time, you have to go to an exam that is testing on this chapter, forces and energy, about all these 5 drawers, and you take 1 minute to draw this picture when you're in the exam hall, and then you are able to use this picture to refer to the answer that you want to answer for the particular questions. Okay, so we'll do one test, which is step number 9, to test how well do you understand the chapter. We already passed 2 hours. Today is a bit longer than normal, but let's see. Let's do the question number 9. Okay, where is it? Okay, let's get a new one. I uploaded the books. Let's see whether I can open it here. Okay, not this one. Okay, I uploaded this book. Just give me a second. Yep. Yes, I uploaded this book. This book is Year 9 IGCSE, Chapter 3, Forces and Energy. As you can see, if I go down quickly, it's talking about almost the same thing that we learned just now. The volume, the mass, the density, right? Then the floating and sinking, and the liquid with different layers, gas and liquids, gas of different density. Then also, these are the question and answers, experiments. Then drawer number 2, now we are going to drawer number 2, heat and temperature. And drawer number 2, you know what are those inside? The heat, the expansion of heat, the expansion of temperature, then this sparkler. Then the next drawer is talking about the conservation of energy. This is the enlist story, right? So we have these calculations. Then we have the transfer of energy, which is the Captain Cristiano Ronaldo, right? You are feeling the heat. How do you feel the heat? Because of I think there are some over here. There is convection, conductions, and radiations, and there's dissipations. This is the transfer of energy. Now, this is the convection, conductions, and radiations. The explanation, right? Radiations. So then next is the. Let me scroll down quickly. Next is the evaporations, and then that's it. So what I did is I uploaded this document into. Hey, where is the slide just now? Yeah, I uploaded this document into ChatGPT and asked ChatGPT to give us 10 questions. Give me 10 MCQ, one by one. Okay. So we will have 10 MCQ. We're going to answer them. So imagine that now you are in the exam hall. You have 10 MCQ to answer. And also at the same time, you draw this picture. You took 1 minute, less than 1 minute to draw this picture during your exam time. Right. First, I would like you to tell me which drawer is this. Let's get Xuan Xuan to start. Xuan Xuan, you read this question and you tell me which drawer is this. Okay, Inje, you want to try first? Okay, let's try.
Density.
Okay, yes. And to give you a hint, usually is in sequence, right? So tell me which answer. Everyone will get their chance to answer the questions.
16 centimeters.
See? Anyone object? Anyone think that it's wrong answer? I'll give you 3 seconds to respond. 1, 2, 3. Okay, let's see whether it's the right answer. Okay, next, be ready. Jovin, be ready. Jovin. Jovin, your mic is off. Which question, which drawer, and what is the answer?
Drawer number 1.
Yes, here, right? Okay, it's talking about these equations. Which answer?
C.
Anyone object? 1, 2, 3. No objection. So everyone agree. MCQ 3. Jaden or Xuan Xuan, who wants to answer? Open your mic.
One.
Okay, Xuan, I hear you. Can you repeat? It's very soft. Your voice is very soft.
Drawer 1.
Still drawer 1. Okay. Which answer?
C.
Any objection? 1, 2, 3. No. Jaden, be ready. Your mic is off.
Drawer 1.
Drawer 1. Oh, yes. Why is it all drawer 1? Okay, it's okay. Okay, which answer?
Honey.
Honey. Any objection? No. Let's hope they will get us other question in other answers, other drawers. Wait. Why is it always drawer 1? Okay, anyway, let's continue first. Yinjie?
Uh, B.
Any objection? Okay. See whether it's still drawer 1. Now I think it's no longer drawer 1. Okay, which drawer? I think the answer is there. Jovin, which drawer?
2.
2?
Mm.
You think so? It's written here. Okay?
Oh, 4.
Yes. Okay, now tell me which answer.
B.
B for boy.
Uh,
Any objection? Okay, this is Jinjie's favorite drawer, but I will not gonna ask her. I'm gonna ask Shen Shen or Jaden, whoever who wants to answer. Which drawer? Both your mic are off. Yes, Shen.
I think is 2, 3. I think.
Yes, you're right. 3. Dissipated here. Elise is being dissipated. Okay. Now, which answer?
B. B for boy.
B for boy. Any objection? 1, 2, 3. No. Okay. Jaden.
Um, the the drawer is drawer 4.
Yes. Draw 4.
Converting into kinetic energy.
B. Is it?
Yes.
Any objection? 1, 2, 3. Okay. Whose turn now? I think it's Yunjie.
A.
Which drawer?
Oh. Uh, I think it's 1.
Yes, it's drawer number 1. What's the answer?
A.
A. Any objection? 1, 2, 3.
I think it's C.
Yes, I think it's wrong. Who said that just now?
Me.
No, who says C just now? Is it you?
Me.
Xuan. Okay, good. Then Xuan, tell me which drawer?
F off.
The Cristiano Ronaldo, remember?
Yeah.
Okay, which answer?
Yeah. C, I think.
Which one?
C.
C for cat.
Yeah.
Any objection? 1, 2, 3. Okay, congratulations. Congratulations. I think now you have some get 10 out of 10, some get 9 out of 10, whichever it is. It's a very good result, and the score doesn't represent the score represent that you are having a good understanding, a very good understanding of the chapter, right? The score doesn't represent that you are able to get A in your IGCSE exam, right? This is the first step. You need to have a very strong foundations of your understanding. And the next step is you need to practice. You need to familiarize with your exam question, which we did not do yet. Because in 2 hours or 2.5 hours, it's impossible for us to be familiarized with the exam question. But in 2.5 hours, to be able to have a strong understanding about the foundation of that chapter, which is this part. Let me pull it out again. This one, together with the picture, is already a remarkable achievement, right? Do you feel that you understood the chapter much more than before you came into the test, into these sessions? Yeah, excellent. I saw Yunjie, right? So what is the time right now? 11点，11点。我们看一下我们刚才几点开始的？我们是8点开始的。因为今天我们的 session 比较慢，有新的 student 进来，我们要慢一点。So it's about almost let's say 2.5 hours, because in between we have break, and also then Jovin came in later. We also spent some time to explain a bit. So 2.5 hours. So not 2 hours, but slightly more, 2.5 hours. So if you think that this method works well for you, then congratulations. You're able to save your 3 weeks worth of job or effort that you need to study your one chapter into, let's say, 3 hours. So the remaining of your time, you can spend it on either on TikTok or either double down on other chapters. Right, I'll just give you one more example. I've gave this example to Jaden and Xuan and Jovin before. I'll tell you again for Xuan, for Yunjie. Imagine now you have how many chapters? You have 9 chapters, right? For year 9, ICGSE. And one chapter you need 2 hours. And let's say we take morning, 2 hours, and afternoon, 2 hours. How many days for you to completely cover the entire 9 chapters? 4.5 days. Let's say 5 days. Okay, 5 days. So from Monday until Friday, if you do this regularly for 5 days, Yinjie, you will have already completed your IGCSE year 9 in 5 days. Before we go to Azerbaijan, you are already an expert in year 9 science, right? So something for you to ponder, how to use this method to help you to save more time and gain more confidence in learning. Okay? Yes. Bye bye, Yinjie. We are done. Thank you.
Bye bye.
Bye bye.
Thank you.
Bye.